Hi, my name is Samantha Cope, and I'm going to speak about the Protected Seas Marine Monitor, a vessel monitoring platform that provides an autonomous and accessible system for monitoring small-scale fisheries activity. I'd like to acknowledge my co-authors, Brendan Tugger and Virgil Zetterlind. Monitoring vessel activity in remote locations is a challenge for fisheries worldwide, and often even more difficult for small-scale fisheries, because the technologies used by industrial fleets may not be available or applicable for them. Also, small-scale fisheries often have minimal resources available for patrolling marine areas, and evaluation of the collected data can also present obstacles to local management. There is a need for monitoring solutions for these small-scale fisheries at an appropriate scale and affordable cost, without compromising the available benefits from existing and new technologies. The primary objective of the Marine Monitor, or M2, is to provide an accessible vessel monitoring platform for resource-constrained managers. M2 uses marine radar, a familiar technology for vessel operators, combined with a high-definition camera to record and report on activity in nearshore areas. Data collected in the field are stored locally on site and transferred to the cloud so that vessel activity can be viewed from anywhere by users that are authorized by local partners. In this presentation, I'll provide a brief overview of the M2 system, share how M2 is helping marine managers autonomously monitor vessels of interest and report on that activity, and identify key benefits for using M2 to monitor marine areas. M2 systems use a commercial X-band marine radar system to monitor vessel activity from shore out to about 5 nautical miles. The radar system is similar to those used on small to medium-sized boats for navigation. The pan-tilt camera is directed to vessel locations by the radar. An automatic identification system, or AIS sensor, records any large vessels that transmit these data. And a weather station provides environmental context and a valuable data point in remote locations. Monitoring in these remote areas is accomplished by outfitting M2 systems on towable trailers with a solar array, battery system, and omnidirectional cellular or microwave antenna. The trailer design is rapidly deployable and movable, as monitoring needs potentially change over time. It also can provide a base of operations for those working in the field. The M2 system is deployed along the coast, and vessel positions are identified in the radar imagery. Then, M2 software uses the vessel positions received from the radar system to construct vessel tracks, showing activity over time. These tracks are presented in a browser-based interface called the M2 Viewer. On the left, users can view vessel records, and on the right, those vessels are shown on the map. You can also see the red area on the map, which is an area of interest to management. Geofencing around areas of concern, like this one, can trigger email or text alerts to users who may be interested in monitoring activity in real time. And the track line provided by radar is at a fine scale, which can be especially helpful when further investigating a vessel's activity and potential fishing behavior. The vessel record displays valuable information like speed and distance traveled. A target confidence score, powered by machine learning in the cloud, rates how likely it is that the track is a vessel, and not waves or rain, which can also be detected by radar. Track data are also recorded and available for playback using a timeline feature for more in-depth analysis. Photos are collected throughout the duration of the vessel's trip, and they help identify what it might be doing. And the current weather conditions are also shown. There are currently 14 active M2 sites, and additional ongoing deployments that are either in progress or in the planning stages, including in a number of small island developing states designated by the United Nations. First, we'll zoom into one of these islands, Quiboquel, Belize, part of Turnef Atoll, where an M2 system was deployed in 2021. At this site, M2 hardware, like the radar antenna shown here, was integrated into an existing off-grid field station on the island. As a popular tourism and diving destination, small vessels poaching within the Quiboquel Conservation Zone may go undetected. An area has also been designated just offshore to protect an active spawning aggregation site for multiple species. M2 helps monitor and document vessels of all types in the area's vicinity. The blue track line in the northeast corner of the area shows that a vessel was idling there, which could be of interest. M2 also captures photos of the vessels so that managers can investigate and respond if necessary. Traveling farther south to Ecuador, an M2 system is used as a mobile command center for managers, where they use radar tracking and the live camera feed to monitor suspicious activity in the surrounding marine reserve. This M2 site was also deployed in 2021 and has been used to identify numerous incidents of illegal fishing. The marine reserve system here protects habitat for a number of species, but it is also an area of heavy fishing activity. In the map on the right, you can see the spatial extent of the reserve and the location of boats in the radar imagery near the reserve boundaries. With M2 systems operating 24/7, a lot of data are collected. Since organizing and sorting through the data requires additional human resources, M2 also automates evaluation. Managers receive data products in the form of emailed PDF reports. They can integrate with expert local knowledge to support decisions related to fisheries. These reports include track and heat maps of all traffic and activities of concern, a breakdown of activity over time, and specific analysis of activity within the local areas of interest. We include separate maps of daytime and nighttime activity, track totals and statistics, and also system uptime and weather information. In conclusion, M2 is a proven technology demonstrating how the power of cloud computing can be applied to data collected locally. Data hosting on the cloud also facilitates exchange of information across multiple M2 sites and organizations. In this way, M2 integrates data and lessons learned about vessel activity from unique locations into the larger digital ecosystem, while also building local capacity for effective management with minimal resources on the ground. Thank you for taking the time to view this presentation, and a special thank you to our featured site partners. If you'd like to receive more information on M2, please reach out to me at the email address shown here or visit our website. Thank you.